All right, students, the first thing we need to do is go to our search bar in the bottom left and search for bridge. After a few letters, you should see Bridge Designer 2016 show up. We're going to open that. There are some boxes that will pop up at the beginning. We'll just hit close and make sure that we are selected on create a new bridge design and hit OK. So there's a few of these setup windows we're going to need to go through, and these need to be done correctly in order to qualify for a grade and in order to qualify for the leaderboard if you're competing. So on screen number 1, we will go ahead and hit next, and on screen 2, we'll hit next as well. But on screen 3, we're going to change the deck elevation to 12 meters, and then we can leave these other settings the way that they are, or you're welcome to change those if you would like. It is possible to get an A with any of these settings in place. If you want to go for the leaderboard, I highly suggest that you don't change any of these settings. But no matter what, you have to have a 12-meter deck elevation for this project. Okay, we're going to hit next. On screen number 4, I have found through a lot of testing that high-strength concrete ends up being a little bit cheaper in the long run, so I suggest changing that. You don't have to, but I suggest changing it to high-strength. We'll hit next and go to screen 5. If this is your first time building a bridge, I highly recommend that you choose one of these templates. With any of these templates, it's possible for you to get an A, but if you use a template, you're probably not going to make the leaderboard because they're not the most optimized bridge designs. I'm going to go ahead and do a template for this instruction. I'll just pick the first one, through truss how, and then we can go ahead and click on finish at screen 5. It brings us to this work screen. We've got a little toolbox in the top with 4 different tool options that we can choose from. And the first one is the joint tool. So this is where we place spots where beams are going to connect on our bridge. Our template shows us where to click to put those in place. So I'm going to go ahead and throw those in. On the deck of the bridge, or the part that you would walk on, those are actually already there. They have to be there standard, so you don't need to click those. They're just already there. The next tool is called the member tool. This is how we draw the bridge beams. You can go ahead and click and drag between these different joints, and it will place beams between. Notice on these long straightaways, I can just click and drag the whole way, and it will make all these separate members for me, so that saves some time. And then we can click and drag and follow this template here. So right now we're following the template. In general, you could put beams and joints wherever you want to, in whatever way you think will create the strongest bridge design. So with this basic bridge in place, we can go ahead and test it. So to test your bridge, in the top left corner, there's a button called Run the Test, Load Test Animation. It's like turquoise. We'll click on that, and it will have a truck driving across to see if it can hold the weight. There's a little box called Animation Controls up here with a drop-down arrow. You can actually change a lot of the settings that change the way that this test looks. The one that is kind of the most extreme is this exaggeration one. In reality, this is what the bridge would look like. It wouldn't be all droopy. But I like leaving exaggeration on because it gives you an idea of where the weakest points are. Notice that you can see the color intensity changing on the different beams. The darker the colors, the closer the beams are to breaking. If the beams are red, then they're close to breaking in compression, which means they're being pushed together really hard. If the beams are blue, then they're being pulled apart, which is tension. So whether it's red or blue, it's under stress and could break. But this animation, by the way, is a repeat. It's not like every time the truck goes, it's weakening the bridge. This is just a one-time thing. And the animation is not necessary. You don't have to watch it. As soon as I hit test, if I look at the top, there's this status icon with a green arrow. The green arrow means it's going to hold. So the moment I hit test, I could see that there's a green arrow. I don't even need to watch the truck go. Now, if we click on the button next to the test button, it's got like a pencil and a ruler on it. It brings us back to the drawing board. The goal of this assignment is for you to build a bridge that is as cheap as possible, that doesn't break. So you want to push it just to the edge of breaking without having it break and be as cheap as possible. So an example of how we might do this, if I select all the beams, notice I'm using my arrow tool, I clicked and dragged and selected all of them. I've got these two buttons here, little square, big square. These will either increase the size of all the beams or decrease. If I go increase, the beams will be stronger, but they'll cost more. If I decrease, then they'll get smaller, they'll be weaker, they'll cost less. So I want to make these all as weak as they can be without quite breaking them. So I just dropped everything by 1. I noticed that my overall price that's listed up at the top here dropped. Before it was at $289, I dropped it by 1, it's now down to $266. I'm going to go ahead and test it and see. Now I immediately see there's a red circle up here, so it's going to break, but let's see where. Looks like that first beam broke. So I can go back out. After a test, it actually will keep the beams marked that broke. So these 4 beams that are marked with red are broken. I can see them on the bridge, or over here, it's a little bit easier to work with. You can see the 4 that are broken on the right-hand side over here. So your goal is going to be to not break, but just get close to breaking every beam while making it as cheap as possible. A couple other factors to note as you're experimenting with this, try and figure this out. There are 3 settings up here that you can apply. With a beam selected or with multiple beams selected, you can drop these down and change the material type. So carbon steel is the cheapest, but it's also the weakest. And then high strength, low alloy is somewhere in the middle. Quenched and tempered is the most expensive, but also by far the strongest. You have to decide which one you want to try and which one will be the most cost efficient. You've got solid bar or hollow tubes. Hollow tubes are cheaper by far, and they're stronger in compression, which means if it's a red beam, then you probably want it to be a hollow tube. If it's a blue beam, like when it breaks, it's got blue lines instead of red lines, then you might want to change it to a solid bar. Solid bars are more expensive. And then on the third option, you've got sizes. So these are actually millimeter sizes, and they go all the way down to 30 by 30. So the bigger we go, the more expensive we get. If I go to the biggest, I'm up to $2 million for this bridge. If I go down to the smallest, well, they're all marked in pink, which means they're too skinny to actually work. So we're going to have to go somewhere. I'm going to start at 220 here. But as you go to perfect your bridge, you're going to notice that not all the bridge beams are going to be the same size. You're going to want to bring some of them smaller than others to try and optimize your bridge. Okay, so for today, go ahead and mess around with the software and see what you can accomplish. We'll go into more detail in the following days with this project.